Dear students, today I want to discuss about two applications of total internal reflection. I want to explain about the principle behind the brilliancy of diamond. Second one, the mirage formation on a hot summer day. You must be knowing that even we throw a little amount of light on diamond, it shines very brightly. Similarly, on a hot summer day, if we are traveling on a road, we get a feeling that there is a pool of water on the surface of road. Even we can see the images of trees that are lying beside the road. The principle behind these phenomena is critical angle and total internal reflection. I want to brief you up about these 2 points, these two terminology. Definitely you must be knowing about critical angle and total internal reflection. Just I want to remind you those 2 basic points again. These 2 things come into picture if a light ray travels from denser medium to rarer medium. For example, consider a light ray traveling from denser medium to rarer medium. If the light ray is incident on the surface at an angle equal to critical angle, light ray after refraction, it just touches the surface separating the 2 mediums, making the angle of refraction 90 degrees. This angle of incidence is said to be critical angle. If we apply Snell's law for this particular case, refractive index of rarer medium by refractive index of denser medium equal to sin I by sin R sin C by sin 90 degrees. Hence you will get sin C equal to 1 by mu D. This is the relation which it tells about refractive index, how it decides critical angle. Second thing, total internal reflection. If a light ray is incident on the surface at an angle more than critical angle, as I am showing here, angle of incidence more than critical angle, then light ray is completely reflected back into the denser medium, and this phenomenon is said to be total internal reflection. So, please remember these 2 points: critical angle, total internal reflection. Now, I am going to explain about why diamond shines even if we throw a little amount of light onto the diamond. There are 2 things to explain this one. First thing, diamond material is having very high refractive index, approximately 2.4, and it is the skill of diamond cutter. It is the skill of diamond cutter to make the light ray to undergo multiple number of total internal reflections once a light ray enters into the diamond. Let me explain it by a diagram. See, let us suppose that this is a diamond which is being cut number of times. Just roughly I am showing you the picture. There would be multiple corners would be there, which is the skill of a diamond cutter. If a light ray is entering into the diamond, it undergoes refraction as it is traveling from air into glass. It undergoes refraction. At this point, it is trying to travel from denser medium to rarer medium. Because of the skill of the diamond cutter, wherever the light ray incidents on the inner surface of the diamond, the angle of incidence approximately becomes greater than critical angle. It becomes greater than critical angle and it undergoes total internal reflection. Once again, here also angle of incidence would be greater than critical angle. Light ray undergoes total internal reflection like that. Light ray is trapped inside the diamond only without coming outside of the diamond because of its extremely small value of critical angle. Hence, wherever it is incident, there we find the bright spots of light which makes us to see the diamond shining. That is the principle why diamond shines very brilliantly. Let me explain about another application of this phenomena, how mirages are formed on the surface of a road on a hot summer day. See, let us consider this case. Imagine that a tree is standing by the side of a road like this, and due to the temperature, high temperatures, atmospheric layers have variable refractive index. If you imagine that air is made up of number of layers, layer by layer like this, if a light ray starts from this object and is traveling through this air medium, you need to understand that as we go up, refractive index increases gradually due to the variation of temperature, and as the light ray is traveling down, starting from here, it is traveling from denser medium to rarer medium, denser to rarer. It gradually bends away from the normal while traveling down away from the normal, and finally at one particular place it will undergo total internal reflection and travels like this. If an observer is standing here, he get a feeling that this light ray is coming from this tangential direction from here. At this location, that observer gets a feeling that image is formed for this object from where the light ray has started. This observer feels that the image of this tree is formed here. He gets an optical illusion that a pool of water is present here. In that pool of water, an image is formed. That is how the total internal reflection is responsible for this mirage formation. It is an optical illusion and an application of total internal reflection. Thank you.